So hi guys, the idea that matter is made up of discrete units is a very old one. Early Greek philosopher Leucippus and his student Democritus named these uncuttable units of matter atoms as early as 400 years BC. Little was known of these atoms, and scientists and philosophers like Aristotle, Reverend Pierre, Robert Boyle, Isaac Newton, to mention just a few, worked tirelessly in their attempt to understand this fundamental particle that made up all matter. Although a lot of work was done, almost nothing was learned. Now, in the beginning of the 19th century, a headway was finally made by John Dalton. While experimenting on gases, he discovered that every form of matter had small particles, and borrowing the term coined by Leucippus and Democritus, he called them atoms. He went further in his study of atoms and made 5 assertions which we know today as the Daltons atomic theory. Listen attentively as we discuss these assertions in detail. The first proposition made by John Dalton was that all elements are made up of tiny indivisible particles called atoms. This theory simply agrees with the assumptions made by earlier philosophers that all matter on Earth is made up of very small and tiny particles that are indivisible, and these particles are called atoms. The second proposition made by John Dalton was that atoms of an element can neither be created nor destroyed. This theory, as put forward by John, explains that an atom of an element can never be made from atoms of another element, and that an atom cannot be broken to give another atom. In essence, he means that an atom of, say, oxygen can never be made to be an atom of potassium, and an atom of potassium cannot be destroyed to give an atom of oxygen. The third claim made by Dalton in his atomic theory is that atoms of an element are alike in every aspect and differ entirely from other atoms. This claim very clearly explains that, according to Dalton, atoms of all elements are unique entirely. He affirmed that there were no similarities between atoms of different elements. Basically, he was saying that an atom of an element like potassium can have no resemblance with an atom of, say, calcium. According to him, atoms of different elements are like white and black, entirely different. Fourthly, Dalton said that when atoms combine, they do so in simple whole number ratios. This law he postulated while working on simple inorganic molecules like water, common salt, magnesium oxide, and others. A simple look at these molecules will lead you to notice that in water, 2 atoms of hydrogen combine with 1 atom of oxygen, that is 2:1. In common salt, 1 atom of sodium combines with 1 atom of chlorine, that is 1:1. In magnesium oxide, 1 atom of magnesium combines with 1 atom of oxygen, that is 1:1. After looking at these compounds, he concluded that these atoms, when combining, do so in simple ratios like 1:1, 1:2, 1:3, 2:3, and other simple whole number ratios. The last of his theories, but by no means the least, is the postulate that all chemical reactions are as a result of the combination or separation of atoms. This postulate is the simplest and most special. It simply means that for any reaction to occur, atoms must either join together with other atoms or separate from other atoms. A simple idea of what Dalton meant with this law is demonstrated here. For water to be formed, hydrogen has to combine with oxygen. And for hydrogen to be formed from water, the atoms that make up the water molecule must separate. Now, these theories helped us learn a lot about atoms, but today, 4 out of these theories have been found to contain false information. Only one of these 5 theories is correct in every sense. Stay with me if you want to find out which one.